Hey guys, it's Brandon. Today we're going to talk about carburetor heat and carburetor icing. It's a very simple concept, but it's extremely hard to understand. I was in that same position when I was working through my private pilot training. Just didn't really understand carburetor icing. I didn't really understand carburetor heat, when I was supposed to use it, when was the potential to get carburetor icing, how would I know I got carburetor icing. So I'm going to make this little short video to help you understand and make you more knowledgeable and just a better pilot because of this, okay? So first off, what is carburetor icing, okay? Well, first off, you're going to have your carburetor. Let's check this out. All right. Well, there's a big hole in your carburetor, and there's this little flapper thing in here, okay? It's called butterfly valve. Whenever you increase your throttle, it opens that valve up more. See that? So full power, you're going to have a full opening in the carburetor, just like that, okay? At low idle, it's going to squeeze off, okay? All right, so how do we get ice to form inside the carburetor? Well, first off, you have to have moisture, which there's always moisture in the air, okay? Now, just because there's moisture in there doesn't mean it's going to freeze up our carburetor. Why would that freeze up a carburetor, okay? So inside our carburetor, it looks like this. You have a little venturi right there, okay? So what happens is, as air goes through the carburetor, it hits this venturi. It's a little restriction, so it wants to accelerate, or has to accelerate that air whenever it goes through the inside of the carburetor. So whenever you accelerate air, what does it do to the air temperature? Well, it always drops your air temperature, okay? So sometimes our carburetors will have a little port that's about right there. See that little screw? You can take that screw out and you can put a temperature probe in there. So what that does is that'll give you an indication of what the air temperature is going through the carburetor, okay? One Cessna 182 that I flew a couple years ago, we took off, the outside air temperature was 77 degrees. The carburetor temperature was right at, I think it was 42 degrees. So it's a big swing, okay? So when do we have to worry about carburetor icing? Well, the main thing is whenever the temperature is below 70 degrees. When the temperature is below 70 degrees, when that air goes through that venturi, it can drop the temperature enough to where it'll be at the point of freezing going through this restriction through the carburetor. If there's any moisture, which there'll always be some moisture, but if there's a lot of moisture, then that will begin to ice up the carburetor. So how do we know that there might be ice in our carburetor? Well, like I showed you, there is this butterfly valve, okay? So, as you can see, there's a big opening, and as I squeeze this butterfly valve shut, it decreases our opening. Well, let's just imagine if we're flying full power with that opening and the carburetor starts to develop ice. What happens is it starts to pretty much just clog up your carburetor. That airflow can't flow through the carburetor, and so since it won't flow through the carburetor that well, we have a decrease of engine performance, okay? So that's number one indication when you have carburetor ice. So let's say that I'm cruising at 2,300 RPMs, and after a little bit I look and our power's dropped down to 2,100 RPMs. I increase a little bit more power, it opens up that butterfly valve a little bit more, power goes back to 2,300 RPMs, everything's fine. A couple moments later, I realize the power's back down to 2,100 RPMs, and I go full power, and I'm only getting 2,100 RPMs. So what's going on is that ice is restricting the carburetor. If I think that's happening, then what I'm going to do is apply my carburetor heat, and that's going to send hot air through the carburetor, and that'll melt off the ice. The ice is going to turn into water. It's going to go up into the engine. The engine's going to run really rough for a couple moments, and after that it's going to clean out. You're not going to have that restriction anymore, and you'll gain all that power back, and you'll be good to go. If you don't understand this, what could happen is you might have carburetor icing. You'll end up putting an aircraft down in a field, probably damaging the aircraft, and all you had to do is just pull the carburetor heat and it would solve the problem, and you would never get yourself into that situation. So very important to understand carburetor icing and carburetor heat, okay? So you don't, if anything happens, you'll be able to solve the issue and keep flying, and everything's perfectly safe and normal, okay? So where do we get our carburetor heat from? We get it from this. We get it from an exhaust shroud. So the way this works is our exhaust coming out of your cylinders goes into this port, and this port. This is just a muffler, and then it dampens the sound going out the exhaust pipe, out the tailpipe, so it's not near as loud. So what we do is we have these little tubes. We circulate good clean air, cold air through here. It's going to wrap around the hot exhaust, and as you can see, there's a little bit of a gap in here. And you stick your finger all the way down in it and stuff. It circulates the air through or around your exhaust, and then it's going to come out this hole, and we can funnel that into our carburetor heat box. Okay. So let's say that the temperature is 30 degrees. I pull the carburetor heat. It can warm the temperature up to 90 degrees. So that's going to be plenty of hot air, and it'll melt off our ice. Everything's cool. So we have our carburetor heat box. So like I said, the carburetor will sit on top of this box. This is where your air filter comes through, or the air comes through your air filter. That goes up through the carburetor and into the engine, okay? The whole thing of the job with the carburetor is just to mix your air and your fuel together, okay? Well, what we can do is there's a little valve in here, and what we can do is as I pull it, you'll see it deflect. Let's see that. Okay? So what I can do is I can have it shut like this to where good clean filtered air is coming up and it's going through the carburetor, or I can pull this lever back and then it shuts off your good clean air and sends your hot air up through your carburetor, and will solve your icing problem, okay? Very simple concept. Like I said, it's hard to read out of a book and understand this, okay? So that's if you have carburetor ice. Personally, I've got over 4,000 hours. I've never had carburetor ice personally because I use the carburetor heat as a preventative measure. I don't want to wait until I have carburetor ice and have the engine trying to die on me while I'm in the traffic pattern or on a final approach. So what I do is I use the carburetor heat as a preventative measure to keep that from happening. So how do I do that? Anytime, rule of thumb is anytime that the temperature is below 70 degrees and you have visible moisture or a lot of moisture in the air, but my rule of thumb is the temperature is below 70 degrees and I'm below the green arc on the the RPM gauge, I will pull the carburetor heat and just let it run hot air through the carburetor. And that's just going to prevent you from ever developing carburetor ice. The only bad thing about that is the carburetor heat that's going into the carburetor isn't filtered. Is that a bad thing? Not really, because you're in the air, so there's less dirt in the air than say you're taxiing around on the ground. There's a lot of loose debris, you know, grass or whatnot kind of coming up. But in the air is you know, just fine. So anyway, just to kind of go back over everything, where we have to worry about is this venturi. The air speeds up going through it. When the air speeds up, then you have to drop in air temperature. When you have a drop in air temperature and you have moisture in the air, you run the risk of developing carburetor ice and blocking this whole mess up inside the carburetor, kind of clogging it up. How do we solve it? Well, we have the hot air circulating through, or around, excuse me, around our exhaust, and we can funnel that into the carburetor heat box, and we can direct that up through the carburetor and melt that ice off. And we can use it also as a preventative measure, so that never really happens. Another thing for you guys to think about is, what if the temperature is below 20 degrees? What happens typically is if your temperature is below 20 degrees, then the moisture in the air is probably already going to be in a frozen state. So if you apply carburetor heat at that point, what that does is it warms the air back up, and then when the air goes back through the venturi, it'll refreeze, but then you're stuck because you've already applied carburetor heat, you've refrozen the air, you got carburetor ice. There's not much you can do at that point. Anyway, so I hope this video helps better explain carburetor heat and carburetor icing, when you need to use carburetor heat, and what some indications that you might have carburetor icing. So hope you guys like the video. Don't forget to subscribe to my YouTube channel and check us out on Facebook and Instagram. Appreciate it.